Hello, everyone. This is JT Keating. I'm the Vice President of Product Strategy for Zimperium, and thank you very much for giving us a few moments of your time. Today's topic is on-device versus cloud detection for mobile security. And hackers do, in fact, have a preference, which we're going to get into here in a second. Before we hop in, the standard descriptions and the standard flow here. At the end, we will have a Q&A session. So if you would like, if you have any questions, please put it in the Q&A, the question box or the question capability. The chat capability we are not using today because we have a tendency to kind of forget to look at it, to be honest. So if you have any questions at all, please feel free to put it in the Q&A, and we'll have that session at the tail end. And then, of course, there will be an archived recording of this for your pleasure, as well as we can make the slides available to you. So with that, why don't we just dive straight in? We like to start a lot of these presentations off with various different stats, and this one happens to come from Zenith, that just kind of sets the stage for something that we all know, because we're here to talk about mobile, is the fact that mobile is the new PC, and in fact, mobile is surpassing the PC and has surpassed the PC in pretty much every metric. This one happens to be the number of minutes per day that people spend desktop versus mobile, and you can see the trend lines are clearly just continuing to separate. We've got other ones that have to do with shipments and all that percentage of the time on the internet is now mobile predominantly, et cetera. So tons and tons of devices all out there in this world, and we're going to be discussing the whole concept of mobile threats and the best ways of where to do the detection. So first, wanted to kind of talk about our actors in today's play. We have devices, and we have the cloud, obviously. These are the topic of the discussion. But we also have crowds, and we have bad guys. And obviously, we have to factor in all of these different components into our analysis. I had to put in Matthew Broderick from War Games just to go totally old school, and also to reinforce the fact that a lot of times people with the hoodie hacker with the dark, these guys are all over the place, and they've got various different methods and various different motivations. Although used to be fame was the motivator, now it's predominantly fortune and/or national interest. And these bad guys, these Matthew Brodericks, have definitely turned their sights to mobile. And you can see various different ways, shapes, and forms that this is kind of playing itself out. Apple and Google, for instance, released a record number of security patches in 2017. Our research team happens to be one of the ones that helped provide them with a significant number of vulnerabilities that got patched. As a matter of fact, 10 times the amount of our closest competitor. So our research team is very, very active. 2/3 of these devices are on out-of-date operating systems. Traditionally, kind of generally, it hangs around 25 to 30% in the iOS world and 70, sometimes +% in the Android world because of the fragmentation going all the way down. But the simple fact is, a lot of people out there with these devices and they're running vulnerable operating systems. One of the biggest differences in mobile is the user is the admin. There's no such thing as patch management. They have to decide when they're going to upgrade. They also decide what networks they go into and everything like that. And so what we end up seeing is a huge number of these devices are out of date because the people just don't do anything about it. And they're sometimes, hey, I updated last time and it slowed my machine down or whatever the case may be. So they just choose not to do it, right? And because they get to choose what networks they go into, they're fertile for man-in-the-middle attacks where the bad guys take over the network. This will be a consistent theme in our conversation today. And mobile malware is continuing to skyrocket. So these threats are everywhere. The bad guys, the real Matthew Brodericks, are definitely taking notice and going this direction. So we have to do something about it. The reality is, people a lot of times are like, oh, how big of a threat is this? Is it really happening? Because most organizations don't have visibility into what's going on their mobile endpoints. So they don't know. Actually, most of them, when we survey them, say, look, I know that we're being attacked, but I can't tell you which devices because I don't have anything on them, right? 100% of our customers have detected mobile threats. I do the, with our team here, we do the global threat report every quarter. And every quarter we go back and we look at the data that we have completely anonymized, but you can see across the board that every single customer has been impacted and protected in our case. Okay, so that, understand, it's out there. Threats are real. The real Matthew Brodericks are out there. They've got fame and fortune motivations, or national interest motivations, or hacktivism motivations, whatever they may be. And so they're going after mobile devices. So get that, check. Now, where should the detections occur? Should they be detected on the device, or should they be detected in the cloud? And there's pros and cons of both parts of this equation. First, let's have a little clarification though, because there's a lot of words that get thrown around, and a lot of hype and everything. And I think it's important that a couple words that sound similar we need to make sure that we distinguish between the two. This is a cloud, and it in fact is a cloud. It's a beautiful picture of a cloud, so that's awesome. This is a crowd. Two different things, right? The cloud is a computing resource. The cloud is where we can actually harness the power of virtualization and harness the power of being able to process a significant amount of data. The crowd is a bunch of people and or devices that can feed data in, but the cloud and the crowd are not the same thing. So they both have value in this equation, which I'll talk about. But I think it's important to kind of remember these, because sometimes there's some marketing that clumps them together and says, we're all about the crowdsourcing, and okay, well, that's cool. That's where the data came from. Now what are you going to do with the data? How are you going to process? And again, the fundamental question is, where are you going to do your detection? So let's also separate two things just for this conversation: detection techniques versus the detection locations. Okay. Because again, these are some things that kind of get lumped together. And I think it's very important to kind of say, okay, let's carve it out. The techniques, what are the most effective techniques? Why should different things be considered in different scenarios? And then, as a function of the reality of mobile, what's the best place to do the detection itself? So two different things. So let's deal with the techniques first. Machine learning is all the rage. We talked about it, that if you walked around RSA or the Gartner Security Summit that we were just in just a little while ago, machine learning is everywhere. AI is everywhere. But machine learning is very, very important and very, very valuable in today's cybersecurity, whether you're on mobile, whether you're on traditional endpoints, like the McAfee's of the world, or if you're up doing SIMs. You need to be able to use some sort of machine learning and some sort of artificial intelligence, because the numbers are just too big. So this is a definition from Forbes. We think it's pretty straightforward. We, by the way, also, this quote, along with a lot of the material that we're even talking about here, we have a white paper that anybody can download off our website that actually explains our approach to machine learning and our thoughts about machine learning. But basically, this is where we're basically saying we're going to train machines to do something that a really, really smart human being would do. Okay. In this case, we're talking about how do you apply, if you could capture all of the intelligence of a super, super smart mobile threat researcher, like we've got the best in the world, and shrink them down and put them onto a device or put them into a cloud, as we're going to have this conversation, to do things really, really quickly. Okay, so machine learning is very important. Why is it important? Because the numbers simply don't add up. This happens to be a malicious app example, but it applies to other parts of the attack chain, the kill chain as well. The numbers are just almost impossible. I mean, we've calculated with the number of mobile threat researchers in the world, they can get to maybe 5,000 to 10,000 true analysis, 5,000 to 10,000 apps per month as a human being analyzing it properly. There's 5,000 to 6,000 new apps going into just the Google Play Store every day. That doesn't count Apple, and that doesn't count third-party app stores. So it's simply impossible. The numbers just don't work. This one happens to be Dirty Cow. It was found in over 1,200 Android apps, and if you go down to the right corner, it was basically said that it's, between 6 million and 21 million times it had actually been downloaded against these 1,200 apps. So clearly something is way, way, way behind, right? So machine learning is absolutely critical. As a technique, it's absolutely critical. But we also fundamentally believe you should apply the right technique to the right task. And I have obfuscated and taken out some of the examples of each one of these because there's no reason to necessarily, tip the hand to anybody that might have nefarious reasons, like Mr. Broderick over there. So some are best handled deterministically. I mean, it's if this, then that. Very simple. Some network attacks, for instance. Very, very, if you know it, it's easy. Some risk analysis in particular are really well handled by crowdsourced data. Things like vulnerability databases, for instance. So the crowdsource of that sort of data and pulling information in is very, very important, right? The things that are really compute intensive should be done in the cloud. They shouldn't be done on a device. And we're going to talk about our approach, for instance, here in the next slide. So if you have something that requires a lot of compute intensity, don't put it down on a smartphone. That doesn't make any sense, right? But then there's some detections that are best and only possible with machine learning, okay? For instance, anything that's unknown, anything that's 0 day, a live detonation of an exploit. These are things that have never been seen before by themselves, but there's profiles, there's behaviors, there's characteristics that make them detectable with machine learning. So we don't need to know dirty cow, for instance, what we were just talking about. We need to be able to detect that sort of an approach because particularly in an enterprise capacity, you're going to be subject to targeted attacks, not to just some random, throw it out in the wild and hope somebody goes after it. Targeted attacks by definition will not have a signature. So you need machine learning as a part of your mix. This happens to be our detection for malicious apps. One of our advantages in the market is we're the only guys that can do 0 day machine learning based detection of device attacks, compromises and elevation of privileges, et cetera, network attacks, man in the middle, rogue access points, et cetera, and malicious apps. So we're the only ones who can do all three of those with machine learning, and we've got proof points behind all of that. But this, just to give you an idea of the process, it started off here in the middle with the little orange dots where our researchers, way back when, because we've been doing this for years and years, installed a bunch of safe and malicious app in the lab, okay? And again, this would be a cloud you could use because there's a tremendous amount of data that comes into this. But this is where we're training it. What we do is we extract and create these methods and go down. And again, our machine learning white paper can go through this whole thing. And ultimately, we create classifiers that are highly efficient at detecting these threats. But we're going through all these iterations, all these permutations in the cloud, basically. Very intensive because you need to go through all the processing and all the crunching of the data, billions of data points from millions of devices. In the end, as we go back through the feedback loop, to be able to do these, to create these classifiers. Once we create the classifiers of unique changes in the system that that create a fingerprint for a particular class of attack, then we can take that classifier, and Z9 is the name of our machine learning based engine. We can take that classifier and put that out on devices. So in our case, we're doing all the training in the cloud using crowdsourced data as it loops back in. So we got the cloud and we got the crowd that are doing the training, but then we actually put the classifier on the device because we passionately believe that you need to do all of your detecting on device. So this is how we do our machine-based learning from a technique standpoint. Now, machine learning is thrown around as a term a lot, and we're asked a lot of times, well, how do I know if machine learning even works, right? Because again, walk around RSA, and if you turned it into a drinking game, you wouldn't get past the first aisle in terms of how many times you hear machine learning. But here are 3 tests that we recommend to see whether or not somebody's machine learning, regardless of where it is, and we're going to get to location next. How do I know it works? The first one is update much. If you go back and if you look at the blogs, or if you look at the white papers, or if you look at the coverage of any given attack, look at what the vendors say about it. And if the vendors finish, like most of them do, with then we updated our software and our clients were safe, it's not really machine learning. If you have to update all the time in order to handle new threats, it's not really machine learning. In contrast, every single device exploit, kernel exploit that's come out since 2014, we've detected on device without updating our software. So that's a proof point. The second one is the law of large numbers, okay? If you go back and read, let's say even the dirty cow example and some of the rest of them we just talked about, if somebody is talking about the fact that there are 10 million downloads, 15 million downloads, 30 million downloads, and they're saying that they've got crowds of millions of people, those two do not compute in terms of equaling machine learning. Because if you actually had machine learning behind a crowd, you would have detected it when it was in the thousands as opposed to millions of downloads. In contrast, we blogged, and you can see it on our site, one of our really good threat researchers did a post on a fake BBC app that we detected, one of our customers down in Australia, and there was less than 10,000 downloads of that app when we detected it worldwide. That's a difference. And then prove it. Just have people prove it, you know, and we are always very comfortable about going in and showing our technology. So we talked about the techniques, use the right techniques, the right time, use the right resources to be able to do it. Fundamentally, back to the question, where do we do it? Well, before we answer that question, we have to look at the reality of the threats that Matthew Broderick and his boys are throwing around, right? Because they're different in mobile than they are in traditional, because mobile is different. For instance, mobile has a hardened operating system. Mobile also has containerized apps. Each app is in its own little bucket. So unlike traditional endpoints, if a hacker comes into an app, they have to find a way of doing something other than that app if they're going to stay persistent, which is what they still want to do. That's totally different than traditional endpoints. What we see from our millions and millions of devices around the world and billions of data points is most malicious apps are completely untargeted and designed for fraud. Things like BankBot, things like that. That's not the way they're going to target you. So let's say that Matthew Broderick wanted to go after XYZ Bank, right? Matthew Broderick is not going to drop an app in the App Store and pray that somebody from XYZ Bank downloads it. What Matthew Broderick is going to do today, not what he did back then, is he's going to sit in a coffee shop across from XYZ, and he's going to wait until he finds somebody from XYZ that connects to his rogue access point, or when he's doing a man in the middle, he's scanning. Once he identifies his target, then he compromises the device. He finds some way of elevating privileges, because that's the only way to remain persistent. And with the unique nature of mobile, it's the only way to actually be able to have any kind of value across the device, because container apps are containerized. So you need to be elevated. You need to be like an admin on the device, which is the goal. So the primary attack vector of a targeted attack is a network attack that delivers some form of device compromise. That is a critical component in this equation, and it is absolutely critical to the question of where should I do the detection? And here's why. Let's say that we wanted to do our detection in the cloud, and almost every, I won't say almost, every good mobile threat defense solution, which is Gartner's term for what Zimperium does, the ability to detect device attacks, network attacks, malicious apps, phishing, and vulnerabilities and risk. We all work with EMM providers like MobileIron and AirWatch and BlackBerry and Microsoft Intune and that group, because one of the things that the operating system, the mobile guys have done is said, we only want one guy to kind of run most of this. The EMM guys are already on there. So as a general rule, this is how it works for cloud-based detection. They will scan the device, they will send that data up to the cloud to where their MTD solution is. Because, by the way, they're doing detection in the cloud, they have to pick one cloud. One of the advantages, side note, this is bonus points, one of the advantages of doing detection on devices, you can go to any cloud you want. Whereas if you're doing cloud-based detection, the vendors had to choose which cloud that they were going to be in. So you scan the device, you send it up to perform detection. Once you detect something, let's assume for a minute, even though it's not true, that everybody's machine learning and everyone's detection is the same. Let's assume everybody can detect everything, which, as we discussed just a few minutes ago, is not the case. But let's just assume that for this argument. You scan the device, you send it up, it gets detected, whatever the attack is. The EMM policy will then be sent over to the EMM cloud-based solution, which goes back down to the EMM agent to actually do the remediation. So this is the flow of cloud-based detection. Well, there's a few fundamental problems with this. The first one is delay. It goes up, it goes here, it goes sideways, it goes there, it talks to this, et cetera, before anything actually ends up happening. Some of these solutions, it's literally in the order of hours before the response comes back. The attacks are occurring at machine speed. You can't respond with something that takes hours, or frankly, even minutes, frankly, even seconds to do, otherwise the damage has already occurred. Second part is, there's some data that gets exfiltrated that might be considered sensitive data. So especially with GDPR and things along those lines, this is a big question mark for a lot of folks. A third that I think is related to this, but I'm just going to give it a little bonus point again. A lot of customers are, end users are not pleased at all when they find out that their data plan is being sucked up by a mobile threat solution. Because every time it goes to cloud, every time it comes back, it's data. Right? So that, especially in places where data is very expensive, they're not pleased with that at all. But the major thing is, and we go back to the slide that I just had just a second ago, the number one way of targeting XYZ bank is a network attack. If I control your network, I control where you go. And so if I control your network, there's no way I would send you to what's going to detect me. So in contrast, we set out from the very beginning and said, we have to stop targeted attacks against enterprises. Zimperium is the enterprise mobile threat company. We've got all these proof points behind it, which we'll talk about in a second. We started by saying we need to protect against a targeted attack. The number one way of attacking a device in a targeted capacity is to control the network. Ergo, we have to be able to do detection on device. And as we discussed earlier, the attacks are going to be brand new, never been seen before because they're targeted, so it has to be machine learning based. Hence the reason I showed you a little while ago, we do all the training in the cloud, but we detect on device. So in our case, we actually do our detection right then and there. And as a part of the detection, if we notice a network attack, we can actually remediate that right then and there because we're doing the detection. We're doing the thinking right there. Once we detect it, we can go up to our cloud, our console, which I'll show you, and as I said, it can be on any cloud. Doesn't have to be just AWS, which is what everybody else is on. Send the remediation, send it back down. So you have the ability to protect yourself. You have the ability to withstand a man-in-the-middle attack. You can detect previously never seen before attacks, and you can remediate it, very, very quickly compared to the cloud. So our engine is called Z9. And it detects these attacks, device, network, and app attacks on device having been trained in the lab. It can be deployed out in one of two ways. It can either be deployed out in a product we call ZIPS, which stands for Z Intrusion Prevention System. This is basically the next generation antivirus for mobile. This is the one that integrates in with the EMMs. And if you're trying to protect the device and all of the data that's on that device, you use ZIPS. We can take that same engine, though, and drop it in. We have a software development kit, an SDK, where you can literally embed all of our detection capabilities directly into a mobile app. It's called Z-App for in-app protection. And so, for instance, we have a customer that is using ZIP to protect hundreds of thousands of employees and using Z-App to protect millions of mobile banking customers. So you can use both. And both of those come into our console. which is backed up by Z3A, which stands for Advanced App Analysis. This is an app reputation capability that we've got that will tell you how risky your apps are, even the legitimate apps. Why does this legitimate app have access to contacts? Why can it turn a microphone on? You know, any of that. And then zConsole integrates back into the largest suite of EMM providers. We also are the only ones that can handle multiple EMMs in a single console. So if you're transitioning from one to another, for instance, or if you inherited two different ones, it doesn't matter to us. Why? Because we're doing all our detection on device again. And then we have the best threat forensics, being able to drop that back into any given SIM solution. And so our differentiators, I've been bragging on our mobile research team. They are literally the best in the world. We're the only ones who can do machine learning-based detection of DNA, device, network, and app attacks. The only one of the major players doing on-device threat detection to prevent the man-in-the-middle type attacks. And we are the most enterprise ready and friendly because we are doing it on device. We can go cloud agnostic. You can do on-prem if you want. We have multiple EMMs, all those different things that come with that, the best forensics. And we also have the best software development kit for embedding this into mobile apps. So with that, I will finish up and see if we have any questions. I don't see any yet, but I will wait a second or two to see if anybody has any questions. But then thank you again for your time. So let's see if anybody has any questions. Okay, I do not see any, which means I must have been amazingly compelling. Thank you guys very much again for your time. This will be archived, and again, we can make slides available, and please download the machine learning white paper that we've got on our website for some additional information, and we will be talking with you all soon. Thank you very much.